All right, so today we'll be looking at set theory, okay, and the objectives for this lesson, okay, is that we need to understand and know the definition of sets. Here I was just saying understand and define sets. We need to know about equal sets and equivalent sets, okay. We'll talk about subsets. So there are two types. We have the proper subsets and then the improper ones. We are going to talk about them. We'll move on to what we call as the power sets. So here you should pay extra attention here because they like bringing this in assessments. The universal sets, I know you know the universal set. Complements, okay, we should also take note of the complement because it confuses students, but I know how to explain it so that you actually understand it. And then the union of sets, intersection, this is what we are doing at grade 12, right? We know how to unionize sets, how to intersect, but we'll review them in case you never took math at high school or at secondary, okay? And then the last thing now will be to solve an example question or example questions. So these example questions, I'm actually getting them from past papers, okay? Because right from the start, I want you guys to be equipped with the skill on how to actually answer exam questions, okay? Meaning test questions, quizzes, and the final exams. I want you to get to know. So each video that I'll be actually hosting here, I'll be putting exam questions so that you know how to solve questions in the exam. So let's start. Okay, so the first thing is the definition. Okay, so if you have any question, just stop me or unmute yourself and then ask. Okay, otherwise I'll just be like presenting. So the first thing is to know what is a set. Okay, we've heard a lot about set. What is a set? What is a set? So a set is simply a collection of distinct and well-defined objects. Okay, so these objects, we're going to be calling them as the members or elements of that particular set. Okay, so it is a collection of distinct, meaning that in that collection, there should be no repetition. Okay, the thing should only appear once. And then well defined, meaning that we can actually clearly decide whether something will belong to that set or it won't. So, for example, if I write this set, right? Okay, so I write set A has, let me say 1, 2, 3, and then all of a sudden I just write D. Okay, will this be a set here? The answer is no, it won't be a set. Okay, because the collection there is not well defined. Because I have numbers and all of a sudden I have D. Okay, the D, what is the D doing there? Okay, so the D is out of place. So it means the collection there is not well defined. Okay, so we are going to say that is not a set because the set should have well defined uh, a distinct object. Okay, so again, if I write my set as A has 1, 2, 3, and then I write 1, 2 again, and then 5. This one here will not be a set. Why? Because all the elements that are here are actually not distinct. Okay, you can see that there's 1 and there's 1. So there's like a repetition of these things that are appearing there, right? So meaning that one is not going to be a set as well. So some examples of the actual sets that we can have a set of numbers, okay? We just end at any number that we like. So here I was saying 1, 2, 3, 4. So we can clearly see that that is a set that has the numbers, okay? There is no ambiguity about it or difficulty in understanding the set. Okay, also if we say the set of vowels, okay, the R, A, E, O's, okay, you can see that um, it's well defined. We all know what the vowels are. So they're just 5 and they are all listed in this set. So it will be a set of vowels there. Okay, another example, it can be a set of colors. Okay, so there's red there, there's blue, there's green. There is no ambiguity whatsoever to understand that that is a set that contains colors only. Okay, so now when it comes to the notation, okay, when it comes to the notation of these sets, we are going to be describing a set using a capital letter. Okay, so meaning like A, B, C, and so on. We're going to be describing a set using a capital letter. And then the elements that are inside that set, okay, if we are talking about numbers anyway, they're going to be described by small letters. So we can say set, let's say set B has maybe C, D, and then E. Okay, so you can see that the letter that is representing the set B, it's a capital letter. And then these ones that are inside there, they're actually what? Small letters. So that's what we are going to be doing. So the elements will be small letters, and then the capital letters will be representing the set. Okay. And then to indicate that such an element, okay, or such a member belongs to this set, we're going to be using this symbol here. Like it's an E, but not really an E. Okay, so it's like you draw a C and then you draw a line like that. So this guy here is going to be indicating that a particular member or a particular element actually belongs to a particular set. Okay, and then when I write this member than or a member of symbol like that, okay, and then I cross it like this with a line, it means not member of. So if I say A is not a member of set A, it means I can't find this A in this set A. Okay, so that's about the notation of the member of and the not a member of. Okay, or you can simply say belongs to or does not belong to. So what is the distinct thing about all the students that are at, for example, Apex? Okay, is that you're going to have the student IDs that are going to have maybe the school logo and the like. So anyone who will be who is found with that identity card, we're actually going to say they belong to what? To Apex. Okay. If you belong to UNZA or some other university, maybe Unilus, you won't possess that such type of an ID or an identification card, right? Right. So that's the definition, and then the notation of what we are going to be using to describe the set. So in the comments, someone saying they're not getting me. Is that the case with everyone? Or you can get me? Are you able to get me, you guys? Hello?
Your voice is low.
My voice is low.
Yes.
Okay.
Yes,
Uh,
now I can get you now clearly.
We can
can
get
get
you,
me
sir.
cleared. Okay,
Yes.
so let me try to just insert the mic again. Um, maybe you try to put some volume on your phone. Maybe it might be your phone, but I've actually put the mic again. All right, so now we move to the next part where we'll be talking about some types of sets that we have. So the first one that we're going to encounter is the equal set. Okay, someone is writing on my screen, Alex Peary. So let me disable the annotations. Okay, so the first set or the first type of set that we're talking about is what we call as equal or identical sets. Okay, so if something is equal or identical, what does that mean? Simply means they are the same, right? Okay, so two sets, we can say A and B, are going to be said to be equal if and only if they contain the exact same elements. Okay, if they contain the exact same elements, we're going to say they are equal. So, for example,
Yes.
if A has the elements 1, 2, and maybe 3, and then B has the elements 3, 1, and then 2. So these sets here, you can see they contain the exact same elements. So we're going to say A and B, they actually what? Equal. They're equal sets. Okay. So from this, we notice that the order actually doesn't matter. Okay. The other one can start with 1, 2, 3. The other one is 3, 1, 2. Or the other one can start with 2, 3, 1. It will be as long as they have the same elements, okay, the order in which we write them inside those sets does not matter. So equal set, it simply means they contain the same exact elements. Okay, so this is very easy. So if they give you a test that has multiple choice, they can actually ask such a question. Okay, they can tell you to define an equal set. Okay, and they like bringing this question together with what we are going to look at next. So I'll skip the cardinality. I'll first come to the equivalent. So what is an equivalent set and how is it different from the equal set? Okay, so when you talk about the equal set, it means those two sets contain the same exact things. But when we say equivalent sets, then we mean that those two sets, they can contain different elements or different members, okay? But as long as the number of those members in those sets is the same, then we're going to say they're equivalent. So the notation to show that two sets are equivalent is actually denoted by this symbol here. So this here simply means A, okay, is equivalent to B. So in some other books, but I think at your lectures, I like using this symbol. But in some other books, in case you are reading a book, don't be surprised when you find this symbol here. So it's like an equal sign, but with three lines. Okay, so even this one here actually means equivalent to. So A is equivalent to B. So meaning that the number of elements in A is actually the same as the number of elements in what? In B. And I gave an example here. So they set A, which has 1, 2, 3, then they set B, which has A, B, C. So if we count the number of elements in A and we count the number of elements in B, they're the same. They all contain three elements or members. So meaning that they are going to be what? Equivalent. Okay, so the question that usually comes is that distinguish between the equal sets and the equivalent sets. Okay, so if for some reasons you didn't study this part in your notes, okay, or you've never watched this video, okay, then you won't know. Okay, so equivalent sets, we are just focusing on the number of elements in those sets. Then equal sets, we are focusing about the actual elements that are in those two sets. They have to be identical. Okay, and then now I can go back and talk about the cardinality. So cardinality of a set, this word here should not scare you. Okay, should not scare you. Cardinality, they just simply meaning how many elements are in that set. That's the cardinality of a set. Okay, so if, for example, my set is this one here, what is the cardinality of A? Okay, I'm just going to say 4 because if I count the number of elements in this set, they're just 4. So that's the cardinality. Okay, and then now, what notation do we use to indicate cardinality? Because in math, they uh, they most want to avoid using words, so they use symbols. Okay, so you're just going to get A and put it between two lines like this. Okay, this will mean cardinality of A. So the cardinality of this set A here is actually what? 4. The cardinality of that set B there is just equals to what? 3. Because if I count 1, 2, 3, they're actually 3. Okay, or if you want, you can use this notation. You can say card A. Okay, it's equals to 4. And then here we can say card B. Card B. Okay, so I'm sure some of you know that American artist Card B. Maybe you listen to her music and the like. So you've been smiling at I found Card B in math. Anyway, so you can also use this notation to indicate the cardinality of a set. And then again, in other literatures or in other books, okay, in case you are reading a book somewhere, the cardinality is indicated as a small letter n, and then you put the set there, and then I'm just going to say 4. So this one also means the cardinality of A. Okay, so you can use this notation, or this notation. But since your lecture gave you this one and this one, don't use this one. Okay, it's going to mark you wrong because it's going to say, who taught you this? And then you say Tutor Poul, then I'll be in trouble. So make sure you use what you are given in the notes, this one or this one. Okay, but just know that we can also express it in this way. Okay, so moving on, we are now going to talk about the subsets. So we have two types of subset. Okay, but before we even talk about the subset, I mean the types of subset, let's talk about what a subset is. Okay, what is a subset? So um, a subset, how can I explain it in simpler ways? So, for example, Zambia, okay, is part of Africa, right? So when you draw that map of Africa, I've forgotten, it's been long since I was in grade 7. I don't know if it looks if it looks something like this. Or what does it look? Something like that. I don't know. But if this is the map of Africa, right? And then we have Kazambia somewhere here. There's the Kazambia somewhere there. Okay. So you can see that Zambia is within the Africa, right? So meaning that everything that is in Zambia, it's also in Africa, right? Is that correct? So everything in Zambia is also in Africa. Why? Because Zambia is actually inside Africa. Okay. So even if we get another country like Senegal, okay, the ones that just won the Africa Cup, if this is Senegal here, okay, we see that Senegal is inside Africa. So meaning that all the people or everything that is in Senegal is actually also in Africa. Okay, that's what it means to be a subset. Okay, so now when it comes to the issue of sets, we're going to say A is a subset of another set, let's say B, if all the elements that are in A, they're also present in that set B. Okay, all the elements in that A, they're also present in that set B. Then we're going to say A is a subset of B. Just like we are saying here, the Zambia here or the Senegal or whatever country that is in Africa is actually a subset of Africa. Okay, so if to write it in terms of sets, we can say, okay, this is my set B here. And then inside the set B, I have this small I have this small set now. I'm saying can't. So this small set, let's say A. So you can see that whatever will be in this set here for set B will also be in the bigger picture there. Okay, so A is actually a subset of what? Of B. So now we have two types of subsets. Okay, we have two types of subset. We have what we call as the proper subset. Okay, and we have what we call as the improper subset. So it's very important to know both of them. Okay, so when is a subset said to be proper? Okay, so a set A is said to be proper subset of B, written as A is a subset of B, if all elements of A are in B, okay, but A is not equal to B. Okay, so meaning that let's say B is the set that contains 1, 2, 3, and then 4. Okay, so if I write now A, if A is it's a proper subset of B, then it means A should not be equal to the set B. So A might contain maybe 1 and 2. That's all. So we see that all the elements in A, they are in B. Okay, because A contains 1, 2, and I can see the 1, 2 in B. So we're going to say A is a proper subset of what? B. Because everything in A is in B, but A is not equal to B. Okay, it has fewer members. Okay, so this is when the subset is called the proper subset. And then now, when you talk about the improper one, we mean this, okay? So the improper one, if my B has 1, 2, and then 3, okay? And then another set A also has 1, 2, 3, okay? Then we are going to say that A is an improper subset of B. So the improper, that word improper subset, it is indicated by this symbol here. So it's just the same symbol for the subset, but you put like a line below it, okay, to mean that actually this set A is actually equal to B. Okay, so if two sets actually contain the same things, then they are improper subsets of each other. Okay, they're improper subsets of each other. So I hope you've gotten the difference between these. Okay, so the improper means it contains everything in the other set. Then we're going to call it improper subset. Okay, and then the proper, it will be just, it contains some part of it. Then it will be what? It will be a proper subset. Okay, and then there are two important rules that we need to take note of when we are talking about subsets. Okay, so the most important rule to know is that every set is a subset of itself. Okay, very soon we are going to be solving questions where we are saying, okay, find the subset here. So every set is a subset of itself. So whatever set that you see is a subset of itself. Okay, and then the empty set is a subset of every set. Okay, so whatever set that you have, just know that the empty set is also a subset of that set. Okay, so meaning that if they give you the empty set itself, how many subsets is it going to have? based on what I've just explained. Anyone who can try. If they give you the actual empty set itself, how many subsets is it going to have? Anyone who can try. Come on,
Can
guys.
you
Come
repeat
on,
the,
come on. I'm
can you repeat
saying,
the question?
okay. So, okay, maybe let me first explain and then I repeat the question. I said every set is a subset of itself. And then the empty set is a subset of every set. So now, if the question says, we have given you this um empty set here. How many subsets does this empty set have? What would you say? Anyone? What would you say? Okay, so they've given you the empty set, guys. Okay, so first of all, we're saying that every set is a subset of itself. So the empty set, okay, will be a subset of itself. And then the other rule said the empty set is a subset of every subset. So it means that empty set is actually going to have what? Only one subset. Okay, because it's a subset of itself, and then the empty set is also a subset of it. Okay, so the itself is the empty itself. Okay, so the empty set only has one subset. I think I saw that question last semester. There was a quiz for not the full-time students, but for the online distance ones. Okay, there was a question like that. They were saying, how many subset does the empty set have? And then they put two, they put zero, and the like. And people filled that question. Okay, so if they ask you, the empty set only has one subset. Okay, and then that will take us now to the formula for the what? For finding how many subsets a certain set is going to have. Okay, so the formula for finding the number of subsets that a certain set is going to have is simply 2 to the power n. Okay, it's 2 to the power n. Then this n here represents the number of elements. Okay, number of elements. So if they give you a set with maybe 4 elements, then how many subsets is it going to have? It will be 2 to the power 4. So now 2 to the power 4, it's not 2 times 4, guys. No, it's not. So this is an exponential, right? So this is what I'm from teaching this for the students at Unilus. So if it's an exponential like that, it just simply means you multiply these 2 by itself 4 times. Okay, so this will be 2 multiplied by 2 multiplied by 2 multiplied by 2. So 2 multiplied by 2, 4. 4 multiplied by 2, 8. 8 multiplied by 2, 16. So meaning that if they give you a set that has 4 elements, it's expected that that set is going to have 16 different subsets. Okay, so usually they can't ask you to list 16 subsets unless otherwise. Okay, the maximum they can ask you to list is 2 to the power 3, so like 8 subsets. 16 is too much, I think, for your level. Okay, yeah, so if the question asks you to find the number of subsets, just know that the formula to use is 2 to the power n, and then the n is indicating the number of what? The number of elements. Okay, right, so it's important to know this formula here. Okay, and then there's this proof here. We'll get to prove it later, but for now we can just talk about it. So here they're saying if A is it's an improper subset of B, and B is an improper subset of A, then A is going to be equals to B. So this rule is also the same if you just say the proper subset. So if A is a subset of B, and then B is also a subset of A, then this will mean that A is equals to B. So later on, we'll get to prove, okay, why this is true. But for now, just have it in mind that actually this rule works, okay? But I've seen some questions in test 1 papers where we are required to prove this. So they'll ask you, given that A is a subset of B, B is a subset of C, prove that A is equals to B. Then you'll be there confused. But it's just a simple proof. So we're going to discuss it later so that you also know, right? So I'm going to discuss it. I promise I'll discuss this one here on how to prove it. But here we're not proving anyway. Okay, so I've discussed everything about subset in full. In proper, every subset is a subset of itself. The empty set is a subset of every set. Okay, and then if A is a subset of B, B is a subset of A, then it actually means that A is equals to what? To B. All right, they are the same things because they are subset of each other, so they're the same things. All right, so now moving on, we can talk about another important thing. Okay, if you remember on the objectives there, I said you should pay attention here because most people, they actually don't understand this part. So power set, what is a power set? Okay, so a power set is a set that contains all the subsets of a particular set. So let me give an example. So if A is the set that has only one like this, let's start with a simple example. Okay, this is my set that has been given. Okay, and then they ask you to find the power set. So to find the power set, you first have to list down all the subsets of that particular set. So what can help you here is actually first finding the number of subsets, okay? So that when you start listing them, you can actually just list them nicely. Okay, so we're going to say the number of subsets is 2 to the power n, but the n is the number of elements. So this set only has one element. So I'll say 2 to the power 1 is equals to 2. So it means this set here has two subsets. So what are those subsets? Okay, anyone who can try. What are those two subsets that this set is going to have? Anyone? What are those subsets that this set is going to have?
The empty set itself
Yes,
and the
one.
one.
Okay, yes, so that is true. So the empty set itself and the one. So the set itself and the empty set. So I can write the set itself here, one, okay, and then I can write the empty set like that. So the empty set, I think I forgot to mention, it has two symbols. You can write it like this, or you can write a zero and then you cancel it like this, okay? If you write your empty set, I've seen some students writing this. If you write it like this and then like that, this is not an empty set. It is a set that contains the empty set. This one here. I don't know if you understand the English. It is a set that contains the empty set. So it's not empty. It actually contains the empty set. Okay. So the notation for the empty set is either you use this or this, not this. This is wrong. Okay. So it means that set only has two subsets. This is one, and then this is two. So now the power set of A is going to be a set that contains all the subsets of this set A. So the power set is indicated by P of the set A, which will just be equals to, and then now you list the subset of that particular set. So I have the set itself, which contains one, and then the empty set like that. Okay, so you can see this is a set that contains the subsets of whatever set that you've been given. That's the power set. Okay, so maybe showing it like this and then now going back to the definition will help you understand what it is. Okay, because sometimes when you're just saying the definitions, it's a bit difficult to understand what you're talking about. Okay, so I hope now you're all clear, right? So the definition here says the power set of a set A denoted by P of A or 2 to the power, whatever letter is representing that set, is the set of all subsets of A. So here I've given a perfect example. There's this set, what contains one, okay? What do we do first? We find out, okay, this set, how many subsets is it going to have? So it's going to have two. Then we list those subsets, okay? And then we get those subsets and put them within a set or put them in a set. That's what we call as the power set. Okay, so I hope you've understood this. I was also giving an example here. I was saying let A have A and B. Okay, so maybe we should go through over it so I can erase this. So A has A and B. So meaning, first of all, find out how many subsets can that set have. So it will be 2 to the power, how many elements it has, which is 2. So this will just be 4 subsets. Okay, it has 4 subsets. So let's list them. So it's the set itself. Okay. Okay, the set itself with A and B, and then the empty set. So these ones, they're always there. The set itself and the empty set. Then the other one will be the set that contains A only. Then the other one will be the set that contains B only. So these are our 4 subsets. Okay, so meaning now the power set of this set A is just going to be a set that lists all the subset that it has. So it will be the empty set, the set itself. We can list them in any order, and then the A and then the B. So this one here will be our what? Our power set. So they like bringing these questions. Okay, so make sure you understand the concept like fully. Okay, you are going to see that once your tutorial sheet is out, there's going to be a question on the power set, and you'll be required to actually answer it. All right, so we move on to something simple. I know these ones are very simple for you guys. We've had the universal set since grade 1, right? So what is the universal set? Okay, so the universal set, denoted by a capital letter U, is a set that contains all the elements under consideration. Okay, so let's say uh, our area of interest is maybe Apex University. So it means the universal set there will be all the students that are at Apex. Okay, and then now from that uh, universal set of all the students at Apex, we can now start getting particular sets. So let's say we get the set of pre-med students, the set of those that are doing medicine in their second year, the set of those that are doing pharmacy maybe in their 5th year. So those will be sets, okay, gotten from the actual what? Universal set of everyone who is at Apex. Okay, so I'm giving the practical example so that you can easily understand it. Okay, so the set that is going to contain all the elements under consideration, that's what we're going to be calling as the universal set. So in the questions under set theory, they'll actually mention that the universal set is such and such. So meaning that whatever you're going to be doing, you should be referring to the what? To the universal set. Okay, you should be referring to the universal set. Right, so I've seen a comment, you are rushing. Okay, so if you don't understand anything, just ask. Okay, be free. Just unmute yourself and then you can ask. Okay, so moving on, we'll talk about the complement. So this one here, it's a very important concept because it will save you from losing marks. Okay, because from my experience, okay, as I've been teaching this course, people usually don't understand what a complement is. Okay, so I'll give a very practical example. So if you yourself, you are at school now, for example, you are at school, and then me, I go to your place. Will I find you at your place? No. The answer is no. You are at school, so I can't find you at your place. And then when you go back to your place, me, I go to your school. Will I find you at school? No, I'm not going to find you. Okay, so that's the concept of about the complement. So you're going to have, for example, let me say the universal set here. Okay, let's say the universal set contains numbers 1, 2, 3, all the way up to 10. Okay, it contains 1, 2, 3, all the way up to 10. And then from here, I get a set A, which contains the numbers 1, 2, 3, all the way up to 8. Okay, so if they ask me now to find the A complement, they're simply telling me find the elements that are in the universal set, okay, but they are not in the set A. That's what the complement means. So meaning that I have A complement here, okay. So whatever numbers that I'm not going to see in the set A here are the ones that I'm going to put in the A complement. Okay, so since A contains the numbers from 1 to 8, then the universal set contains numbers from 1 to 10, it means 9 and 10 are in the A complement because I can't see them in the set what? A. Okay, so the secret is this. when you add what is in the set with what is in the complement, or what is in its complement, you should get back the universal set. Okay, so if I were to unionize the A and the A complement, I would get back my what? My universal set, because it would be 1 all the way up to 8 and then 9, 10, which makes up the universal set. Okay, so the complement of the set, okay, is the set of all elements that are in the universal set, but they are not in that particular set of interest. Okay, so for example, if the universal set is Zambia, okay, I think Zambia is too big. Let's say the universal set is Lusaka, right? And then there's Apex, which is the university where you're going, and then there's maybe your boarding house. So those can act as the set and the complement. So meaning that we are all in Lusaka, okay? But if you go to school, or if you go to the university, or you go to campus, it means if I go to your boarding house, I won't find you, okay? But the boarding house and the university, they are all in Lusaka like that, okay? So that's how easy you can actually understand the complement. So the notation for the complement, sometimes it will be a complement like this, or sometimes just be A and then like that, Kasimbo. So whenever you see this, or whenever you see this, it actually means complement. So meaning the elements that are part of the universal set, but they're not in that set. Okay, so this one here, it will be appearing frequently in the questions. You're going to see as we are solving some of the questions here. Okay, and then what is next? The union of two sets. Okay, I believe everyone knows the union of two sets. Well, you're just getting this set and this set, then we put everything that they have together. Okay, so meaning if set A contains 1, 2, and then set B contains 3, 4, the union of those sets is going to contain 1, 2, 3, 4. So we are getting everything in those two sets, bringing them together, okay, making sure that if there's one element that is actually repeating and is present in both of those sets, we just write it once. So let me just write down that. So if A has 1, 2, and then 3, okay, and then B has 3, 4, and then 5, then A union B is going to be equals to, okay, I just combine everything that I can see here. So there will be 1, 2, and then 3. So there's a 3 here, and there's also a 3 there. So the union set, make sure you don't write the things that are repeating twice. Just write it once. So you just write the 3 once, and then you go on to the 4 and to the 5. So this one here will be the what? Will be the union. So in the union, make sure you don't repeat any number. Okay, and then next we talk about the intersection. So the intersection now is what is common between the two sets. Okay, or what I can say what is common between you and your siblings. Okay, what is common there is you came from the same parents, like that, right? So the intersection, it's what is common between the two. So I think this is the easiest. So you look at set A, it has maybe 1, 2, 3, and then set B has 3 and 4. So what is common between those two sets? That's what we call the intersection. So now, this is set builder notation. So I'm avoiding to talk about set builder notation because that's another lesson for another day. Okay, so you're going to describe it something like this. Okay, but they will never ask you for a definition of the intersection of two sets. No, such a question will never come. But how to use it, definitely to come. Okay, so I think we've discussed all the things that we needed to discuss today. Okay, so now we'll look at some exam questions based on the same things that we have talked about. Okay, so here is a summary for those who have forgotten what we've discussed. Okay, we did the definition, the set notation, we did the equal and equivalent sets, the subsets, we explained what the proper and the improper are, the power sets, the cardinality, the universal set, complement of the sets, union of the sets, intersection of the sets, and then now we are moving into this important part here, because this one is the one that is going to make you actually clear the course or pass the course. So we solve some basic exam style problems on the concept that we've just covered. Okay, so sample exam questions. So let's move to the first question here. So here, guys, I expect you to start asking questions, okay? Because we are starting now to use the concept, okay? So I know using the concept can somehow be confusing, but we'll try to understand. So make sure if you don't understand, ask, okay? Because if you don't ask, you won't know, and time is moving. You see that very soon the lectures will be moving at the speed of light. Okay. It will be notes after notes. So make sure you understand. So the first one here is saying, let's set X be having the elements A, B, C, and then Y be having the elements A, D, C. Write down in roster form. So roster simply means listing form.
Yeah.
Okay, so listing form is the same as whatever has been given there. So write down in roster form the power sets of X and Y. Okay, so we said the power set is just the set that will contain all the subset of that particular set. Okay, so for X, this one has A, B, and then C, right? Okay, so that's what it has. So I said the first thing that you do is find out, okay, how many subset does this set have? So it will be 2 to the power, how many elements are here? 3. So this will just be 2 multiplied by 2 multiplied by 2, which is simply what? 8. So it has 8 subsets. So we need to list about 8 subsets here. Okay, so the first one, you can start from the easiest one. So you can say the A itself. Okay, by itself is a subset. The B by itself is a subset. The C by itself is a subset. And then when we are done with the ones that are your combine, you are getting 1, you go to the combination now. So I'll combine A with B. So I'll say A and B. Okay, and then I combine A with C. So it will be A and C. Okay, so I'm done combining the A with the B and C. I go to B combining with the what? With the C. So it will be B and C. Okay, so how many sets have we written so far? We've written 6. So now there's usually a confusion here because someone will say, okay, now let me go to the C, and then they will write C and A. Okay, so no, you don't do this because C and A is the same as A and C because this set and this set are actually equal. So you are writing one thing twice. Okay, so that's going to violate the rules of the set. So don't do this. You're going to get it wrong. Okay, so just write it once, like the way I've done there. Okay. All right, so I have 6 subsets here, and then now I'm just going to add the extra 2. So extra 2, we know them, right? It's the empty set and the set itself. So the other one will be A, B, and then C, and then the other one will be what? The empty set like that. Or you can actually represent this with the 0, and then you cancel it. So the set that is going to contain all these subsets here will be the power set of what? X, like that. So that's the power set of X. Okay, so any questions there? Any questions there, guys? Okay, so if there are no questions, I'll move to the next. So here they said find the power set of X and Y. So I'll leave the Y for you so that you also practice, right? Okay, so I'll leave the Y for you. So at your own time, you can actually screenshot whatever is on the screen there. So make sure you take a screenshot and then you find the power set of Y. Okay, once you find it, you can actually send to me. You know my number is there in the group, and then I'll be able to tell you if what you're doing is correct or you need to uh, work hard for you to understand the concept. Okay, so you can find the power set of Y on at your own time. I'll move to B. So B, they're saying find the power set of X intersection Y. Okay, find the power set of X intersection Y. So the power set of X intersection Y, it means first I have to find the intersection of X and Y. So what is common between X and Y? I can see what is common there is the A and the C. Exactly. So A and C is common. So we put it there. And then now, okay, we ask ourselves, what is the number of subsets here? So it will be 2 to the power 2 because there are 2 elements here. So this will just be 2 multiplied by 2. So I have 4 subsets. Okay. So now these 4 subsets, I have to list them. So the first one is A itself. The second one is C itself. The third one is the set itself. And then the fourth one, we know the culprit, right? So that's the empty set. Okay, so now this one here will be my power set of X intersection Y like this. So this is my power set of X intersection Y. Okay, so if there are no questions, I'll move to the other one. So the other one there, they're saying find the cardinality of P, of P now. Find the cardinality of the power set of X union Y. Okay, find the cardinality of the power set of X union Y. So now, we said cardinality is what? Anyone who can remember? We said cardinality was that? Hello? We said cardinality was what, guys?
Hello. It is
Yes?
the number of elements in a set.
Exactly. Okay, so now here we just want to know the number of elements that are going to be in the power set of Y union, of X union Y. Okay, so let me erase this. So the first step is to find the Y union, X union Y. So the union, we are combining everything here and everything there. So meaning that we have A, okay, B, C, and then the D. So this is Y union. Why do I keep saying Y? Okay, so this is X union Y, right? So X union Y has these elements here. Okay. And then here they're asking for the cardinality of the power set of X union Y. So meaning how many elements are in the power set of X union Y? Okay.
4.
4, right?
Yeah.
Are you sure it's 4?
Hmm.
How many elements are in the power set of X union Y? Are you sure it's 4? So no, it's not true. Okay, so the elements in X union Y, they are 4. Yes, you can see them. They are 4 here, right? Okay, but the elements in the power set of X union Y, they are not 4. Okay, they are not 4. Okay, so how can we find them? Okay, how can we find them? So I'm going to say here, this X union Y, it has 2 to the power 4 subsets because there are 4 here. So this is what? 16. Okay, so the number of subsets that this set is going to have is going to be the cardinality of its power set. I don't know if you've gotten that. Have you gotten that?
Yes.
Yes. Huh? Someone hasn't gotten it. Okay,
Repeat.
so we're saying, first, let's find X union Y, right? So X union Y is this one here. Okay, so now how many subsets are there for the set X union Y? So to find the number of subsets, we just said it is 2 to the power the number of elements that are in that set. So the number of elements that are here are 1, 2, 3, 4. So it will be 2 to the power 4. Okay, so 2 to the power 4, it will give me 16. So meaning that this set here has how many subsets? 16 subsets. Okay, it has 16 subsets. And then this set, power set of X union Y, what does it contain? The power set contains all the subsets of that particular set, right? So here, the subsets that are going to be in this power set of X union Y, we are going to list 16 subsets there in that set. Okay, so now what is the cardinality of that same power set? It has 16 subsets, so it has 16 elements. So the elements that will be in the power set will just be 16. As simple as that. Okay, I don't know if you've gotten it now. Have we gotten it?
Yes.
Yes,
Okay.
but do we need to list them, those 16, or you just leave it like that, the answer?
No, we don't have to list them here because they didn't ask us to list them. So you can see the question, they're just saying find the cardinality. So you just have to find how many they are.
So the cardinality is 16.
Yes, the cardinality is 16.
Okay.
All right. Okay, so we move to the next question. This one here.
Oh, sir.
Again, oh, someone has a
Hello.
question. Yes,
I wanted
you
to
can
ask,
ask.
so the answer is just to write 16 or
Yes, it's just write 16. So you remember the notation for the cardinality? We said if this is a set A, if we want to find the cardinality of this, we draw two lines like this, and then we put the A in between like that, right? So here we find the cardinality of the power set of X union Y. So we're going to say the cardinality of the power set of X union Y is actually equals to 16. Okay, so you did good to ask that. I forgot to write this. So you write this as your final answer.
okay, thank you.
All right. Okay, so we move now to the next question here. Okay, still on the same concept. I just want you guys to actually assimilate the concept. So this one is saying, let A be the set having A, B having A and B, uh, C having A, B, C. By listing all the subsets of each of the following sets A, B, and C, show that the number of subsets uh, the number of subsets of a set having n elements is actually equals to 2 to the power n. So it's like they are telling us to prove that formula, the one that we've been using to find the number of subsets. And specifically here, they just want us to use whatever set they have given us. Okay, so the first set that they have given us is A. So I'll write set A here. So set A has only one element. Okay, so here they're saying by listing all the subsets of these sets, A, B, and C, show that the number of subsets of a set having n elements is 2 to the power n. So now when I look at this set A, how many subsets does it have? Okay, so the power set of A is just going to contain the A itself, which is just the set itself, and then the empty set like that. Okay, this is going to be the power set of, uh, or maybe I should not write it in terms of a power set because here they just said list. Okay, so this one will be not fully correct. So they just said list. So let me list. So it's the set itself and then the empty set. Okay, so this one here has how many subsets? We can count them easily. It has 2 subsets, right? Okay, so now this means here is that here I had only one element, right? And then the number of subsets are just 2. So meaning 2 to the power 1 is actually just 2. Okay, and then when I go to the next, I can hear some background noise. Let me just mute them from here. Okay, so when I go to the next set, which is B, B has A and B. So what are the subsets of this set here? So it will be the A by itself, the B by itself, okay, and then the set itself. So meaning A and B, and then the empty set. Okay, so these are the possible subsets of this set here. Okay, so there are how many? There are 4. So this 4 is simply 2 to the power 2. And coincidentally, we have 2 elements there. Okay, let's try for the third one. So C is equals to, we have A, B, and then C. So how many subsets is it going to have? So let's list all of them. So we start with the single ones. Okay, these ones don't like dating. Then we go to the B, and then we go to the C. Okay, and then now we start combining them. So A with the B, okay, and then A with the C, okay, and then B with the C. Okay, so as I said, don't say C with the A again. No, because C, A, and AC, they're just the same. Okay, so what are the other two subsets that are missing here? Okay, it's just the set itself and then the empty set. Okay, so we can count them 1, 2, 3, 4, 5, 6, 7, 8. So this will just be 8, and 8 happens to be 2 to the power what? To the power 3. Okay, so here I was supposed to write it like this so that it follows through. Supposed to write it like this 2 is equals to 2 to the 2 power 1 like this. So you can see as the number of elements are increasing, even the number of subsets is increasing. And then the power on the 2 is actually increasing. Okay, so if I have one element, it will just be 2 to the power 1. If I have two elements, okay, it will be 2 to the power 2. If I have three elements, it will be 3 to the power 3. So you can just write these two lines, do, 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 and then you write set D. It's just going to have A, B, C, and then you write do, 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 okay, until it has like n elements, okay? So a set that contains n elements, okay? And then when you list all the subsets, you'll find that whatever number that you're going to get for the number of subsets that you're going to have, okay, you can express that number as 2 to the power n like that. Okay, we're just following whatever number of elements that are here. So here, to be precise, you can even write n elements inside that set D. So let's write n elements here. Okay, so if I have n elements, it means whatever number that you are going to find here, you can actually express it as 2 to the power what? N, following the number of elements that we have there. So why are we confident in saying that? Because we have three examples here that have actually showed us that that is true. Because when I have three elements, I have 8 subsets, which is just the same as 2 to the power 3. If I have 2 elements, I have 4 subsets, which is the same as 2 to the power 2. If I have 1 element, it's the same as 2, okay, which just gives me 2 to the power 1. So the number of elements there are just powers on the 2 to indicate the number of subsets that we are going to have. Okay, so once we do this, it means we've shown this part here, the first one, okay? And then now we can go on and use the results because the other question says, hence, find the number of subsets of a set D, which has which has A, B, C, D, and these are 4 elements, okay? So meaning that the number of subsets that are going to be in that set will just be 2 to the power 1, 2, 3, 4. So that will be 4, and this will just be 16 subsets. Okay, subsets. I almost wrote subjects. Okay, so subset. All right, so any questions there?
Or is it a mandatory that you just have to add the powers? If you miss the powers, then
Can you repeat the question? I didn't get it clearly. You're saying
like, is it a mandatory to include the powers?
which powers? Like these
What?
ones that we are including here?
Yes, yes.
Yes, for this question, yes. It depends with the type of question. So for this one, yes, it's a mandatory because we are trying to prove that a set that will have such and such a number of elements is just 2 to the power n. Okay, so you are finding the number of subset that that set has, and then you are trying to express it as a 2 to the power something. So it's a must here.
All right.
All right. Okay, so that's how we can simply answer that question. Okay. All right. So let's look at the last question for today. I think that is enough. It has been, I think, over 1 hour now. Okay, so the other question here is someone has a question?
Yeah. I was asking, do we have to show the working when we are answering the questions, or we just write answers?
You show the working.
So
Okay, you show the
to be
working.
powerful,
Yeah, so this one, you show the working.
and the 2 to the power 4 equals to 16 is
Eh,
is it the final answer?
yes, it's the final answer for this last part of the question.
Okay. Thank you.
Yes. All right. So you can only not show your work if maybe they give you a quiz or a test that is in multiple choice form. So you can do the working somewhere else, and then or the multiple choice you just pick the correct answer. But if there are no multiple choice, then you have to show all the working. Okay, so now let's look at the last question here before we start dozing in the class, right? It's late. So here they said let U, okay, be the universal set that has 1, 2, 3, 4, 5, 6, all the way up to 10. And then set A has 1, 3, 6, 8, 10. Set B has 2, 4, 5, 8. And then set C has 1, 4, 6, 10. Okay, so let these be the subset of this universal set U. Find the following set. So the first one is A intersection B complement, and then they have a complement here. So for us to solve this here, we first have to simplify the set that we've been given. Okay, so how do you simplify? So we are just going to multiply throughout. So you've seen this complement that is outside the brackets. We're going to expand it or distribute it to everything that is inside here. So if the complement, okay, goes to the A, I'm going to have A complement. Okay, if the complement goes to the intersection, it will change it into the union. Okay, so master that. If the complement goes to the intersection, it changes into the union. So meaning if a complement goes to the union, it changes back to the intersection. Okay, so this complement going to this intersection, it will turn this upside down. It becomes the union. And then now here I have the B complement, and then I distribute the complement again. So the rule is that if I have two complements like this, the complements cancel each other, just remain with the B. So complement to the B complement is just B. Okay, so meaning that what we have here as A intersection B complement and in brackets and then complement is the same as A complement union B. So for me to find this set, it's the same as I find this. Okay, so I know my set A has 1, 3, 6, 8, 10. So meaning my A complement will have what? Okay, it will have all the elements that are in the universal set, but they are not in A. So meaning 2 is going to be there. Okay, 2, 4 is going to be there, 5 is going to be there, 7 will be there, and 9 is going to be there. So these are the elements that I cannot see in the set A. Okay, but they are part of the what? Of the universal set. Okay, they are part of the universal set. Okay, so that's my A complement. And then now let's unionize this A complement with the set B. So meaning we're just adding everything together. So it will be A intersection B complement, and then complement is equals to A complement union B, which will just be equals to, okay, now let's combine these ones and these. So I can see 2, 4, 5, 7, and then there's an 8 in B, so I write the 8 here, and then 9. Okay, so this here is the combination of the A complement with uh, the B. Okay, so that's the answer for part A. Okay, part A, this is the answer. If we go to part B is C complement union B, and then I have the complement outside like that. So the first thing you do is to distribute this complement to whatever you have inside here. So this complement to the A complement, the complements are going to cancel each other. So I'm just going to remain with A. And then the complement to the union is going to turn it upside down. So it will be now intersection. And then the complement to the B is going to be B complement. So here we're looking to intersect B complement with the A. So let's write the B complement here. So B complement is just all the elements that are not in B, but they're in the universal set. So B has 2, 4, 5, 8. So meaning 1, 3, 6, 7, 9, and 10. They will be in the complement because they are not a part of B. They're not of the part B. Okay, so that would be my what? That would be my B complement. Okay, so now I'm intersecting the B complement with the set A. So meaning I'm looking for common elements between A and B complement. Okay, so A has 1, 3, 6, 7, 10, and then this one has 1, 3, 6, 7, 9, 10. So we see that 1 is common, 3 is common, the 6 is common, and the 10 is also common. So it means this set here, we simplified it into this, is actually equals to that. Okay, so any questions there, guys? Before we move to the next one.
I have a question on A.
Yes, you can ask.
On B, you were cancelled in this complement, which are A complement union B whatsoever, like you cross the bracket. Now
Which one?
I'm
This
asking,
one here?
yes. Now I'm
Uh-huh.
asking on question A. Is it
Mm-hmm.
okay to cancel those C's?
To cancel the what?
To cancel the C's, the complement, sorry.
On A,
Mm.
yes, we actually canceled one of it because we are distributing. Look, we have this complement here. Okay, just a minute. Okay, so I was saying here, you can see this, right? Okay, so there is A intersection B complement, and then there's this complement outside. So we said for us to solve this, we first have to distribute this complement here to everything that is inside there. So if I take this complement to this A, it becomes A complement. This is what I wrote there. Okay, then if I get the complement, I take it to the intersection, it turns the intersection into the union. So this is the union that I wrote there, okay? And then this complement to the B complement, okay? These two complements are going to cancel out each other, okay? They'll cancel out each other. That's why you can see this B here does not have any complement because this complement canceled out with this complement like that. Okay, and then once we simplify it like this, it will be very easy to get the answer that we got there. I don't know if that is clear. The one who was asking the question.
Right, clear.
All right. So it's actually the same thing that we did here. We distributed this complement to the A complement, we got A. Then the complement to the U, we got intersection. And then the complement to the B, we got B complement. B complement. And then we got the set A. We found the set B complement, and then we intersected them. We found they contained the 1, 3, 6, and the 10. All right, so I hope that is clear. Let's look at the last two, or I'll just solve maybe one. The other one, you can try it out. So the first one here on C, they're saying A intersection B union C. So let's first find A intersection B. So A intersection B is what is common between A and B. So what is common between these two sets here? Okay, so I can see that what is common there is just 8. It's the one that I can see in set A and also in set B. 8, only 8. Okay, and then now this A intersection B, I'm unionizing it with the set C, which contains 1, 4, 6, and then 10. So this is the set C there. Okay, so we said union We're just getting everything and putting them together, making sure that nothing is what is repeated. So if I get this and this and put them together, I'm going to have 1, 4, 6, 8, and then 10. Okay, so that's the answer there on part C. For part D, you can try it out. Okay, so any questions, guys? Now we are done for today. Any questions on whatever we've discussed today?
No question.
Okay, awesome. So I hope someone has a question. Ask. Someone has a question. I heard someone wanted to ask.
We are saying thank you so much. At least we get to understand even the things that we did not learn in class.
Okay,
Wonderful.
okay, that is great. That is great. Yeah, so that's the aim. Okay, so that's the aim of discrete learning is to just simplify the learning so that you guys are able to understand. Because we know
How I
not
wish we
everyone
can understand
who
more.
not everyone will understand like in class when the lecturer is teaching and the like. So that's why we're here to fill in those gaps. All right,
Especially
so
on the chemistry, on
on
the moles
chemistry.
and what. We didn't get anything.
All right, no problem. I'll explain. I'll actually send videos so you can try to watch the videos first.
Yes.
That I've taught your
Yes.
friends before. And if you don't understand, we'll still have a live class to discuss. So I've put an
Okay.
assignment here that you can just practice on the power set. So just screenshot and then you can solve them at your own time. And then once you're done, you can inbox me your solutions. I will let you know if what you're doing is correct or it's actually not correct. All right, guys, have a blessed night and thank you so
Wait,
So
much.
session
wait,
nga
wait,
bakutumira naye omuntu minekoka.
wait. Wait, I have a question. Wait.